Welcome to the CIAT Scotland East Region Knowledge Exchange webinar. So on behalf of CIAT Scotland East Region, I'm very happy to introduce speakers from Faro Technologies. So they will be discussing the application of Scan-to-BIM and point cloud technology for architecture. So this webinar is a continuation of our building modeling for architectural technology session. And before I formally introduce our speakers, I'd like to take a few moments to remind everyone about the CIAT Scotland East Region Knowledge Exchange series and our 5 sessions. So this started for us back in March of this year, and we have been running knowledge exchange webinars to provide a dissemination platform for those within the architectural technology community to share their knowledge and experience across 5 sessions, 5 different topics. So we have formally launched all 5 sessions now. With this particular webinar, we will be adding to our building modeling sessions, and we'll continue to add to these 5 sessions over the coming weeks and months. So please do keep an eye out on the CIAT Scotland East Region LinkedIn page for more details on that. So today's webinar marks the second event in the building modeling session. And today our speakers are from Faro Technologies, and they will be sharing their knowledge and experience of the hardware and software to apply scanning technology to architectural projects, with a focus on applications of Scan-to-BIM and point cloud workflows. So joining us today is Martin Laverty, Accounts Manager at Faro, covering architecture, engineering, construction and 3D manufacturing. Eric Rowland, Field Application Engineer at Faro. Both Martin and Eric will be discussing the meaning of point cloud and Scan-to-BIM, examples of the hardware and software involved, what the workflows look like, how can the outputs be augmented with existing software, and the power of scanning as built models and the resources and support offered by Faro for the construction industry. So Martin will kick us off, and that's about 25 minutes. Now, I know both Eric and Martin have a huge amount of stuff to cover, so we can't cover it all. So please do feel free to connect with Martin and Eric in the future. But Martin's got about 20-25 minutes to get through, and then we'll hand over to Eric. Eric has about the same. Then Martin will come back on, and Martin will introduce us to some of the resources available. And then we'll move to questions and answers if we have any and have some time. So Martin, I see you've got your screen up. Brilliant. I've got your main slide there. If you're ready, please kick off.
Yeah, thanks, John, and thanks for the invite to talk today. I'm just going to try and cover a little bit about Scan-to-BIM, point cloud, some of the options that Faro can actually offer for that, just to make the workflows easier. My colleague Eric is going to talk about some as-built modeling, what you actually do with the point clouds once they've been generated. So hopefully it should be a fair bit of information for everyone. So just to start, we'll look at Scan-to-BIM. So basically what we're doing is we're generating point clouds. Those are a collection of points, represent a 3D shape or a feature or a building. Each point has its own XYZ coordinates and also additional attributes, and in most cases that's going to be RGB values, so you actually get a colour point cloud. Architectural point clouds will be made from hundreds, if not thousands, of scans, and you can actually generate billions of points, so you will generate a lot of information. The point cloud info will then be interrogated by BIM software. You can generate dimensions, and then you use that point cloud as a kind of guide or framework to create your models. Some of the software that we have can actually semi-automate the modeling process. CAD software like Autocad and Revit will connect to our as-built system, and what that does is it will look at a product catalogue like structural information or pipework. When you click on the point cloud, it will try and fit that structural information or pipework through the cloud. So it always does a best fit for that. So basically means it's kind of semi-automating the process for creating the model in the background. Some examples on here, I scanned Clava Cairns up at Inverness, and then the other image on there is basically creating a structural model of a bridge that you can see on there. A little bit about Faro. Basically, I'm based in Glasgow. I'm sure the accent gives that away. But our UK headquarters is Rugby. We've got a European headquarters in Stuttgart. Asia Pacific is Singapore, and then global headquarters is Lake Mary. But we are based worldwide. We do have customers, and we do have account managers worldwide to support everyone. Bit of background in myself, as you've already seen. I cover 3D manufacturing, I cover architecture, engineering, construction, and I cover Scotland and Northern Ireland, so I definitely get all the best accents. I've been with Faro for the past 4 years, and I got a bit of technology background, I would say. Eric is going to be covering some of the information as field applications engineer for France, and based in Paris, and a lot of experience in oil and gas and surveys. A little bit more about Faro. As I say, we cover 3D metrology, so that would be inspections for components and assemblies, AEC, which we're just about to cover, and obviously public safety and forensics as well. Most of this, there's a bit of crossover in the hardware. It's just different software that we're using to interrogate the data that's being generated on there. We like to class this as traceable construction. You can see there's a design, build, and operations loop. But what we've got on here is what's actually being generated. So on-site capture, we'll be using the hardware like the Focus S, the Swift, the Freestyle, and then the Scene software. We then pass that information on from Scene into your as-built or your modeling software. So this would be your CAD stuff, and this is where you're creating your model from the point cloud. We then have design layout. We have a system called the Tracer, which is a laser projector, and it projects CAD information. And you can basically pick a feature on the CAD to project. So that could be an assembly, that could be an outline, and that will project that onto that to guide operators through where things are being assembled. We then have quality control. So we have Build It software, which is a separate piece of software. You can basically take your point cloud, you can compare it to CAD. You can also compare it to a previous scan. So you could be doing scans of buildings year on year as it goes through the whole design life cycle, and you can check as it's being built and then after, and then basically see if there's any degradation. Obviously for oil and gas, when they're doing surveys, they're checking for corrosion. So we would scan something now, scan it in 6 months, and then compare the 2 point clouds to see if anything's changed. Then once at the bottom one here, we'll get data connect and share. Obviously with these layers here, we're generating thousands of bits of information and tons of information. So we'll have to be able to find an easy way to share that. So we have web share, which is a web-based system. You can upload point clouds, you can store information on there. So we have a kind of full workflow on here. The main thing is on-site capture. How do we generate and create these point clouds? The main one we've got here is the Faro Focus. This is what most of our customers are using, and this is how they generate their point clouds. There's a little video here, which we're just running just now, which should give you a bit of information on that. Unit itself is pretty small, as you can see on there. It's the size of a large box of tissues. Easy to use, touchscreen. And then what we've got is it's a high dynamic range camera, so HDR, 165 megapixel, and very, very accurate. Does on-site compensation. And what you also have here is you've got an accessory where you can attach other items to it, like panel cams or LED lights. Runs off battery power, so very easy, just charge it up and use it, and we can do spare batteries. Obviously, to use it in Scotland, it has to be IP rated, so it's IP54, so that's sure and dust proof. Temperature range is -20 up to 55, and since this is Scotland East, we'll be closer to -20 than 55, I would say. But yeah, that's pretty much it for the Focus. I'm just going to pause this here. You can see it sitting on the tripod here, so this is how people are using it. As you can see, it's very, very light, so you can pick this up, do your scan, move to the next position. It's designed to be manually moved, nice and simple. As I say, the unit itself is quite small. They're accurate to plus or minus 1 mil at 10 meters, so again, highly, highly accurate. Built-in camera, it's 165 megapixels, so you get your LiDAR scan, and you're also getting your panoramic image, and it's very highly detailed. Just to go to the next page, I'll try not to bore you with too many tech specs, but we've got 4 main models. M70 is the entry model. That does 70 meters range, plus or minus 3 mil at 10 meters, and does 500,000 points per second. And again, that's classed as entry level. We then moved up to the S range, so it's 1 million points per second. That's a bit more accurate, plus or minus 1 mil. And then the plus models, which go up to 2 million points per second. So you're generating a phenomenal amount of information with these. The example on here is a 3D point cloud from the HQ down in Rugby. When I show you the scene software, you'll basically be able to see that I can view this whole thing in 3D. I can manipulate the data, I can do measurements on it, and then I can export it to start generating information. I will skip this. The next system we've got is the Swift, and this is more for kind of mobile mapping if you have to cover large areas, but it's basically the unit on the tripod. Tripod goes onto a kind of golf cart trolley, and then you move this around, so it's actually scanning as you're moving. It means it's very, very easy to use, and you capture lots of information. I'll skip that video and go to this one. But what you'll see on here is a scan that we've done with the Swift system. This took about 10 minutes. The scan itself was all done internally. That kind of orange line you can see on there is the actual path that we walked around. But you can see on here we've generated a lot of information from this. You can see it's black and white. This is your LiDAR image. We're not using the camera because the unit is moving, so we can't use the camera for that. But you can see on there, this is the sort of information you're getting purely from the laser itself. Once I've got this into my scene software, which is how we've generated this video, we can then export this into our modeling software, start constructing models from this. So you can see on here that's a very, very quick system to use and generates a phenomenal amount of information. Part of that is the scan plan. That's a kind of 2D scanner, which you can use handheld. You just walk around and just build up a basic 2D model of a building. But this runs off a phone, so you can use an iPhone or an Android phone. That does the actual processing. It'll create a 2D map. You actually use the camera in the phone to actually take critical details, so you can take photographs on here. But these will also connect to panel cams. So you could do a 2D outline of a building, connect it to a panel cam, and take basically a 360 image, and then import that image into your actual 2D plan. These can then be exported in DXF, PDF, obviously seen in WebShare, but that means that you can actually bring this into your CAD software and start using the 2D plan as a basis for your model, and the images as the basis for your model as well. We also do drones. You can attach the focus scanners to the bottom of the drone. You can actually fly about and then scan the information as you're moving. I've got a couple of videos that are running on there, but basically you can see that this is capturing full streets. It could be towns, it could be campuses, it could be an oil rig, a gas processing station, railway station. You can see on here it's generating tremendous amounts of information. Again, because it's moving, it's black and white, so it's just a LiDAR image, but tremendously detailed, as you can see in some of these. We're capturing the full street. You can see the junctions, you can see the rail lines, you can see all the overhead lines, and then obviously the buildings themselves. And let's say once you see this for the first time, it's incredible. We also have the BIM mobile, and in this case means you can actually attach it to a car. We've had it on the front of a kind of train system as well for scanning railway lines. Apparently you can put it on a bike, but to be honest, I wouldn't fancy that myself. We have had it on the car. Basically, one of my colleagues was scanning I think it was the M40 or the M42 when it was being upgraded, but basically it meant that they were scanning the on and the off ramps, driving past it at 45 miles an hour. And generating the point cloud from that. The last one on here, I think for the Black Mirror fans, we basically have the Boston Dynamics, the spot. So basically the focus goes on top of the unit, you program the route for the robot, and then it travels about, it stops and it scans and it builds up a full point cloud model. basically autonomously. This is obviously for sending it into places where you wouldn't want to risk a person. So if you're sending it on to basically quarries and mines and sort of dangerous gas environments and everything like that. But yeah, this seems to be the way things are going. People want more kind of automated scanning and survey data. Next bit of hardware we have is the Freestyle 2, which is a handheld unit. I've seen a lot of interest in this for oil and gas, for scanning sort of pipe work in sort of awkward areas. I think for historic environment type areas, you'll see a few bits of this as well. But what we've got is a quick video on here showing the scan itself in action, the point cloud being generated, which you see on the phone, and the point cloud itself. So I'll just pause that there. That is an example of a point cloud from the Freestyle itself. That would have been captured in 2 or 3 minutes. It's a very quick system to use. We can actually take point cloud information from the Freestyle and then stitch it into scans from the focus. So as I said, you can use the Freestyle for sort of awkward areas and then bring them into your original scan. You can also use it to fill in the gaps if there's any gaps that have been created, if you missed anything in a previous scan. So yeah, it's a really good system that we brought out recently. The next thing I'm going to talk about is the scene software. This is what we use for processing data. So obviously we're using the hardware to generate the point clouds. Scene is actually processing the point clouds itself. I'll jump on to scene in a second, but just to give you an idea, we simplified the workflow. Technically, you work from left to right. You're scanning something, you're creating your project, you're importing point clouds, you're processing them, you're doing registration, then you're doing exploration. And when you're in Explorer, you view the project, you go into VR, you can create clipping boxes just to clip out items that you're interested in, you can create meshes. I think the big thing for you guys is that you're going to be exporting information. We can export in pretty much all the standard formats. Obviously, we see a lot of E57 and sort of recap for Autodesk, but if you're using anything else, we give you the option to export that. So this is where you're bringing the point cloud information into your CAD system. What we do have is Scene actually runs in VR as well. Got a little video here of a scan of a construction site. What we're doing is we're bringing in the sort of heating system model to that. So the heating system isn't technically there yet, but we're viewing that in mixed reality. So in the VR view that we've got here, we can look to check for clashing, any issues that might be arising. We can jump to different positions in the 3D point cloud just using the menu system in the VR, and then we can add like annotations and reports. We can add comments. All of this can be put in here, but this shows you the sort of power that you're getting from Scene for visualization. I mean, even in Scene as well, I can generate fly-through videos of a part or a component or a building, and that's all done internally in Scene. You can share them online, you can send them as videos, everything like that. But it's a very powerful system. It gives you a lot of control over what you do, and then you can export the information to pretty much any system that you want. I'm just going to pause that there because it's just finished. So what I'm going to do now is come out of the presentation and I'm going to jump into Scene. So can I double check, can you guys now see my Scene screen?
Yep, it's coming through, Martin.
Cool. Basically, this is an example of a scan that I've done. So this is the People's Palace in Glasgow Green. What I've done on here is I've scanned around the front of the Dalton Fountain. it's captured all this information, it's captured all this stuff in the background. With Scene, as I've said, the workflow is left to right. I can actually control my scanner through the laptop. The scanner itself has Wi-Fi, so I just connect to the station and I can basically turn on the scanner and start scanning. Do a thing called on-site registration, where as I'm scanning, it's actually building up a 2D map. So it's giving me an overview of what I've scanned. So basically with on-site registration, it starts the sort of back-end process and it registers information for me. But what that does is that shows me if I've missed any areas, are there any bits that haven't been covered. This is quite a big thing because we deal with a lot of oil and gas. Obviously, if we're sending surveyors out to a rig, there's time and cost involved on that. The guy goes out and he's missed a section. It's a bit of drama getting them back out again. So with on-site registration, you can actually see what's being covered. Obviously, with project information, it tells me what I've got for this project. I've also got my project history. If I screw something up, I can revert back to the previous one, so it gives you an option for that. And then the big thing in here is import. It's drag and drop. I can take scans and bring these in. So as I go around, if I scan the back end of the building, the glasshouse section, I can basically bring that in and then add that to my scan. So you can bring in other projects. You can import information from WebShare, which is the system we've got for sharing. Next up is processing. I can basically process my scans. I can look for targets. I can run a moving objects filter and get rid of random people or cars and stuff in the background. We then have registration. As you can see on here, I've done 16 different scans. So I register all these together to get a complete point cloud. Most of that can be done automatically because I've got enough coverage, but I can use manual registration, visual registration, and I can even import surveyed points. So you might have a control system that is on a construction site or a rig. You can bring these in, and because those control points are in the scans, they then stitch together using that target information. When I go to explore on here, you can actually see that in this case I've got viewpoints that I've created. I can also do clipping boxes. So what I can do on here is I can clip out the background and just focus on the information that I'm interested in, and I can jump to different positions from here. And I'm just using the mouse keys and page up and page down just to control the view on here, and I can control this on here and then rotate around. What I also have is, because I've got a camera in these, I can actually jump to the camera image for each section, so I can zoom in and out, get all the detail in that, and I can open these whenever I need. But this is where all the color information is being generated from. If I come out of this project, so take me to my main scene screen, and what I've got on here is a scan that I've done with the Freestyle, the handheld unit, and in this case it was some oil and gas pipe work. This was sitting outdoors on a pallet, as you can see. This was a 3-minute scan, and basically just walking around it and capturing the information, so you get tons of detail from this. In this example, I've actually modelled that full pipe. We've created an inspection report where we've compared the pipe to the as-built model. We've done a full deviation map on it, and we've extracted all the features from it as well. What I do have here is an example of the Swift scan. So this is the mobile scan that I've done. Again, you can see this is in black and white. Viewpoint, so this scan was done in about 6 or 7 minutes from the top of my head. But you can see on here, basically just a factory warehouse, scanned all the information. And again, I can export this and send it off to my CAD system just by going to export here and clicking on the point. So if I want to export point clouds, these are my options on here. E57, pretty much default format. Recap is going to be Autocad, VRML, DXF, points. There's a lot of ways you can export this. We've always kind of designed scenes so that you can take this information into your own system But again, this gives you a kind of example of the information that can be generated just for some really quick scans. One of the options in export is web share. So basically what happens is that we let you create a web share account. So I've got one here, which I will click on. And basically that lets you upload the scan to the cloud. So we use Amazon Web Share for this. We also do Web Share Enterprise. So basically this lets you store the information on your own servers if you're worried about security or anything like that. But yeah, you can see the scans are on here. I've got an example scan. So this is Glasgow Central. You can see I've actually got the photographic image. I go to my overview map here. Here's all the scans that we've set up for this. And if I go to this scan here, I'll do the other one. So again, this is the panorama scan from the front of it. But if I click on 3D here, this will show me the 3D image from this position. You can see it's filling in all the detail and all the point cloud. And again, I can use my arrow keys and move around, so I can just fly through the full building here. One thing I will point out is with web share, it's doing a lot of compression. You got these billions of points online, so it looks a little blockier than what you do see it on when you actually do the scene software or your CAD software. But like I say, this is the kind of information that you'll be generating. As I say, I can then export that and then start creating and constructing models from that. We also have a system called Build It. I'll just jump into that one. So Build It allows you to do analysis, as I've said. So we can do cloud-to-cloud analysis, we can do tank analysis, we can do floor flatness, wall plumbness. And then what I've got here is we've got an old scan here, a tank. We're allowed to share this one because it's that old. But what I have done here is deviation analysis on that. So what that is actually showing me is a full 3D deviation map of this point cloud of the tank. So green is intolerance, blue is low, and red is high. I've also got the tank report, which I can actually attach to the point cloud. So I've got a volume report on there, got my tank deformation report. When I click on it, it'll bring up this report here. So again, that shows me that. The report's got sections, so it's telling me deviations at different heights. When I scroll all the way down here, it's generated a lot of information. I've actually unrolled the entire tank and it's shown me the deviations across that as well. You can generate a lot of information from that and then upload that so that your customers, your clients, they can see that straight away. The tags I can add can include links or documents or videos, and as I say, that's why we've got the reports on here themselves. But yeah, that's pretty much it from my side. So what I'm going to do is, if I click the right item, I'm going to stop sharing my screen and hand over to Eric. And Eric is going to start covering some of the information for as-built and mod-on.
Okay, good afternoon, everybody. Thanks, Martin, for the first part. So now we'll see the as-built for Autocad and for Revit that will help you to extract data from the point clouds and to be able to use the data with or Revit or with Autocad. So in this example, you will see the different things we can do with the point cloud inside Revit. For example, we'll be able to extract some areas. So we'll not remove the data, we just clean the data, but we do not delete the point clouds. In this example, we can extract the walls very easily with as-built for Revit. We can extract the wall directly on the point clouds. We can extract the windows. We can extract the doors, everything you need to rebuild your buildings. So everything inside Revit. We can extract also families of equipments. So you can generate families directly from the point clouds and reuse these families into your Revit projects. We can use the same as any Revit project, all your levels, all your families you are usually use with your Revit project. As you can see, it's very, very easy to crop and to just select your parts. You can also, with as built for Revit, extract piping. So for all your map projects, that will be very, very useful. And you can have your data the same way as it is extracted with the point cloud, capture with the point cloud, or use it the way you want to build it. You can also extract steel structure very easily. So, and everything with as built for Revit models. In few minutes, you are able to extract walls. You are able to generate the windows, the doors, and at the end, you are able to see if your walls are straight or if you have some deviations. You can do exactly the same for all your outside and to see the levels and regenerate 3D drawings. Now we jump to AutoCAD. So with AutoCAD, we'll be able also to select some areas. You will be able to generate some shapes. We are able to extract very easily edge. So that will help us to reconstruct all the 3D, to do concrete, to do walls in that case. So we generate directly 2D drawings on the go. We are able to use also as built for AutoCAD with Civil 3D and to generate all the drawings accordingly. We are able to generate piping. So we'll see an example later on to extract the data as it should be. We can extract all the beams, check all the levels, etc. Everything inside AutoCAD, from the point clouds to the native AutoCAD data. So we can check if, for example, a vessel is flat, not flat, etc. We can rebuild areas of bridges, for example, very easily. So directly from the point cloud or from the help of the photogrammetry. And each time we generate native 3D data directly in AutoCAD or in Revit. In this part we see section, it's very easy to take dimensions of the, for example, of the bridge. From everything we extract from the point clouds, we can generate proper documentation. In this part, we'll see wall extraction more in details. So you will see in this example, we start from scene. So we have finished our project. We can select some areas or not, and we'll export this project into recap format. So it's very easy. We do everything from scene. When it's done, we start a new project in Revit. We'll insert the point clouds very easily. So this command is just a Revit command, nothing fancy. It takes few seconds to appear. After we just select the views, so we remove the areas of point cloud we do not want, and once it's done, we'll create our levels like a normal Revit project. So it's very easy. We just move the point clouds. We'll see later on that we'll be able to share the coordinates between scene, Revit, and the final data. So in few seconds, we prepare our projects. We'll in this area, we just do a section in order to prepare with the help of as built for Revit the extraction of the walls. So it's very straightforward. We just select the area where we want to extract the data, And after, by 2 clicks for each walls, we'll extract all the walls. So once the preparation is completed, we just have to click 2 walls. The walls will we use the include family of the Revit project. If the walls is not detected as a family, the software will propose to adjust the width of the wall with the reality, and we can reuse this new family directly in the new extractions. So you see, it's very easy to extract the external walls with the internal walls in the same commands. So in few minutes, we'll be able to extract all of the internal walls. And after, we'll just have to adjust the perpendicularity between each walls, and that will be done almost automatically. In that case, adjust the perpendicularity of the walls, and I will add the remaining walls. So in few seconds, we'll have the 3D models based on the 3D point clouds. In addition of the as-built or Revit, we have also a small plugins that is linked to Scene, and that will help us to extract all the walls also directly from the quick views, and to be able to adjust the position of all the doors and all the windows very easily just by clicking points in the window in the picture. The advantage of these techniques is that we are sure that we are clicking only the good points, and we are sure not to select a point that is behind the scene. And as you can see, immediately each time you click the right amount of points, you have the 3D model that appears directly into Revit. So it's very straightforward, and honestly, to be able to use as-built software, when you know by knowing Revit or not, it's just a couple of hours to learn the software. Very easy. Now I've got few snapshots that show you that the extraction of the walls with the point clouds, that is very easy. So with the point clouds without, and we are able to check the flatness of each walls directly into Revit with the helps of as-built for Revit, the plugin as-built for Revit. And for example, to extract data from a point cloud to generate this type of the 3D models, it's just 3-4 hours, and you arrive to generate this model based on the point clouds. So it's very, very easy. Now I will show you the extraction of piping inside Autocad. So it's more for the one who use the map area. So this example is in oil and gas. So it's an area in scene. So I just select a small area. After I will export to recap the same way than for Revit. So it's very straightforward. We export when it's done. So depending on the size of your project, it can be more or less a few hours, but it's straightforward. When it's done, you open AutoCAD, you insert the point clouds. So in that case, we use the as-built for AutoCAD plugins to import the point clouds. And the first manipulation will be to select the area where we want to extract the different piping. So it's very easy. So the best way is to take some time to select the right area, to remove all the parts we don't need, like piping supports, vessels, things like that. So it's with the tools we have with the plugins, it's very easy. So you see in a couple of seconds, I will be able to select only my piping. And when it's done, I just have to select my specification of piping. Of course, we will have to save the drawings. And in that case, I'm selecting my specification. I will take all the components I want, and I will prepare my drawings for extraction. The same way we did with the Revit to extract the wall. It's more or less the same times. And after, I prepare my work with some layers. And when it's done, I just have to extract my piping. So to do that, I click points on the pipe. I'm selecting my elbows, my reductions, my valves, my flanges, and I control every components I've got on my piping. So in a couple of minutes, I will be able to redo this manifold. When the software, for example, proposes the wrong part, because, for example, in some areas I don't have enough point clouds data, so I just have to say no. For example, it's not an elbow, but it's a T. So I will just have to change in the panel, and very quick, I will be able, for example, here to import a valve, reorient the valve, add the flange, the contact flange, the gasket, the correct reduction, the elbow, the piping, the flange again, and quickly close and finish my piece of pipe. So you see, very quick, I can finish my inlet outlet of each pipes. The only thing is that I have to conclude the pipe is to constrain the piping generated with the point clouds. So we try to be as close to the reality as possible. And in few minutes, I did this pump inlets. After, I will extract the data. For example, I will extract this data into Plant 3D to be able in few seconds to generate some isometrics directly inside Plant 3D. So I just have to select my drawings and I can generate my isometrics very quick. When it's done, I've got the 2D drawings with my bill of materials, all my dimensions, all the parts that I have extracted from the point clouds are here. And it's very quick, straightforward. Everything I show you, it's from out of the box data. Now, to conclude this as-built presentation, I will show you Faro as-built modeler. That is a module that is look like scene, that is provided with the two plugins as-built for Revit and as-built for Autocad, and that can be very useful for all the companies that use software that are not Autodesk. You will be able with the software to extract flat parts. You will be able to extract also cylinders, and you will be able to export this data into DXF, STEP, IGES, and to be able to be very easily imported into, for example, SolidWorks, Archicad, software like that. So you will be able to extract planar surface, cylinders. You will be able also to extract 2D vector maps. That is very useful when you want to generate 2D drawings and when you don't have AutoCAD software and as built for AutoCAD, for example. With this software, you will be able also very easily to link your data with with Revit and AutoCAD, and to share the coordinates between the two software. Means that each time you will click on a point on as built for as-built for modeler, for example, you will be able to export these points directly to AutoCAD at the correct coordinates, or Revit also at the correct coordinates. That concludes my part. Sorry. Just to show you the 2D vector maps. So you can extract the walls, the floor, and each levels you want to do. So you can extract in the XF in vector mode. So this is some parts that you can very easily reuse in any software that can read DXF, STEP, and IGES. That's all for me.
Yeah, thanks for that, Eric. I'm just going to share this screen, guys, and this is pretty much it from us. So hold on a second. What you should see on here is some information on links to basically our knowledge base, which is just knowledge.faro.com, and Faro Academy, which is learn.faro.com. If you go to knowledge.faro.com, you'll actually be able to download trials of the software that you've seen today and watch some kind of extended videos and actually download some sample data so you can try these workflows yourself. I would really recommend that, especially the as-built stuff that you've just seen. Obviously for Scene itself, we've got point cloud data for that. If you go to WebShare, you'll be able to see some examples that we'll put on WebShare as well, move around those. I would say if you get any other questions, you can put some questions into the chat, and I think we'll try to answer most of those. But if you need any more information, you can contact myself directly. It's just martin.laverty@faro.com, and my contact mobile number is on there, and you'll also be able to contact John or just put a request in the chat. If you're not based in Scotland, I will be able to put you in touch with a local account manager. But I would say the big thing is if you have a look at the knowledge base or even just the Faro website, faro.com. But like I say, the KB will give you guys trials and sample software, or sample scans, so that you can try the workflows out and see how quick it actually makes things. You'll see a massive difference, especially when it comes to as-built. But that is pretty much that from ourselves. I think I'm going to hand back to John just for some finishing up. But thanks for everyone's time today. I know we've tried to cram as much of this as possible into the time that we've got. There's so much more to talk about, but hopefully we've not taken up too much of your time, and hopefully we've given you a few things to think about. But I'll stop presenting now, and I'll hand over to John, okay?
Superb. Thank you very much, both Martin and Eric. To make my last slide up again, just with our own details, I can share my screen and we can wrap up. So there was thanks very much both Eric and Martin also for not just the presentation and going through an awful lot, and there was a huge amount there, and it's amazing to see just how far the hardware and software has come along, because I remember exploring this technology, about less than a decade ago, and there was an awful lot of tracing you had to do. So once you got it out of the scanner into AutoCAD, as it was back then, there was an immense amount of time you had to spend retracing over stuff just so you could snap to things and take measurements. But the Scene software itself looks very capable, but now having those export functionality and having that kind of ray tracing type of process is just phenomenal. You have answered all the questions, which is fantastic. I just want to have a kind of question of my own, really, again, because we used to use this technology a long time ago. It was about the registration process. It might be yourself, Martin. I'll just kind of I'll throw it open to both of you. It's only one question, and then we can kind of draw to a close while I'm sharing my screen. But the in terms of the on-site application, so you're kind of preparing to go to a building. You've got this building to scan. You may be doing an internal retrofit, or you might be doing a conversion or a change of use or something like that. So step one, go and get some asset information and you scan that. I remember back in the day, you had to go and get a bunch of checkerboards or targets and things like that and pin them around the place. And then whenever you got it into a piece of software like Scene, you would then use those checkerboards or those kind of balls on tripods so that you could manually register everything together. It seems like that's kind of a thing of the past. In terms of the lead-in time and spending time on site, prepping the site, what's that kind of process look like? Do you need to move things out of the way? Do you need to put checkerboards up in more complex geometry? What's that kind of process look like on the ground for a surveyor?
I think for some of the larger scans and sites that you would do, you probably still would have some of that as a control system to refer back to. But when you're doing a lot of these scans, as long as you have overlap between the scans, and the software will actually tell you once you've registered what the overlap is, it should actually register that automatically, especially on the same sort of floor. I mean, most of the scans that I've done as examples have been basically no checkerboards, no targets. I think the only thing I've really used the targets for was when I scanned clava cairns, because that wasn't regular features and regular walls, that was trees and grass and cairns and stuff. But yeah, most of that, as I say, the automatic registration just makes things simple. As I say, you have to have overlap between the scans. That's one of the big things. As I say, that's why we kind of brought out on-site registration, because as you're doing that scan, that's showing you the 2D overview map that it's creating, and you'll see that if it does actually, if there's not enough overlap between it, it will say that it's kind of broken the chain. It'll continue going as you're scanning, but what you can then do is go back and scan in between the 2 points where it's the chain's been broken, and it fills in the gap for you. So it makes that very, very easy. If you're going to be doing stuff where there is a lot of where it's going to be covering over information where you're not going to get overlap and everything like that, then that's when you would start using your target systems and your checkerboards, just to make sure that, yeah, there's enough information there. But yeah, it's far, far easier to start scanning now just with automatic registration, just as long as you've got the coverage in there.
Yeah, superb. I'm just wondering, would you have to, if you're doing a kind of a hybrid thing where you're using, if you didn't have the drone with the LiDAR attached to it, if you're using just kind of off-the-shelf drones from other pieces of hardware for photogrammetry, it doesn't have the same resolution and certainly doesn't have the same amount of accuracy as you would have if you're scanning with LiDAR. If you're trying to stitch that together, something that Eric had mentioned in the chat in the answers, if you're trying to stitch that together, is that you best doing that inside Scene? Could you import your photogrammetry into Scene, or would you need to do that in your destination software, Vectorworks, AutoCAD, something like that?
I can answer on this one. So today we are relying to a third-party software to do that. So we can use different software. So what the idea is to mix the photogrammetry with the focus data to ensure the fact that we have the same scale.
Yeah.
And but we always use the same project in order to apply the photogrammetry to the scene project.
Yeah.
At the end. So that is the idea, and we bring back everything into Scene. Yeah.
Perfect. Right, I think we've come to a natural end there. And if there's any questions in the chat around budget and cost and things like that, we'll put you in touch with Martin and Eric, and then they can have that conversation. But yes, this is just a kind of the start of the conversation. Really, we're hoping to have Faro on again in the future to kind of talk a little bit more about this. But please do reach out to the Faro guys, and if you are in Scotland, Northern Ireland, Martin can redirect you. So thanks again to everybody for joining us this afternoon. We know you've got a choice of places to be, so thanks for spending it with us. Any questions we don't get to, we'll pass it on to the Faro team and get answers to you on the LinkedIn post. Thanks again to Martin and Eric. And please do keep an eye out on the CIAT Scotland East Region LinkedIn page for upcoming events on the building modelling series. But for now, thanks again, and we will see you all at the next one.